Okay, continuing on here with number 12. This was one of the most frequently missed questions from the formative. Hold on, trying to get full screen. Doing this in the dark. There we go. All right, so if we have the sine of an angle as -1/5, and the angle lies in the fourth quadrant, my hope is your first step was to draw this angle. The angle lies in the fourth quadrant, goes all the way around to there. Its sine is -1, which means that's got to be the opposite side, over 5, which means it has to be the hypotenuse. And so I'd say the angle looks something like this. There's our theta with a -1 for our opposite side. 5 is the hypotenuse, and now all it takes for me to do is get the adjacent side. Both secant and tangent require the adjacent side. Secant is the reciprocal of cosine, and so it would be hypotenuse over adjacent. And then tangent obviously is opposite. I don't know what that was. Opposite over adjacent. And so we just need this adjacent side. Pythagorean theorem says that the adjacent side, I'll call it b here, b squared plus -1 squared should equal 5 squared. So we've got b squared plus 1 equals 25. B squared equals 24, and therefore b equals the square root of 24. Some of the biggest mistakes where students did not put this in simplest radical form. It should be pretty obvious that 4 is a factor of 24, and so a 2 can come out, and it's 2 radical 6. So that's the adjacent side is 2 radical 6, which means I've got 5 over 2 radical 6 here. And that would be, I'd multiply the numerator and the denominator by radical 6 to get it in simplest radical form. So I've got 5 radical 6. The radical 6 multiplies by itself and eliminates the radical. So it's just 2 times 6, 12. And here I have -1 over 2 radical 6. That radical 6 is not in simplest radical form, being in the denominator. And so I've got -1 radical 6 over 12. These were the two answers for number 12. And number 13, I want to know the x-intercepts. The graph looks like this. We have shifted the entire graph pi over 2 to the right. When the amplitude is 3, that's not going to affect our x-intercepts. It's just going to make our peaks and our peaks higher and our troughs lower. So what I started with here was just x and sine of x, and same standard angle values as normal: 0, pi over 2, pi, 3 pi over 2, and 2 pi. And that gives us 0, 1, 0, -1, 0. So right now our x-intercepts would have been 0, pi, and 2 pi, but everything moved pi over 2 to the right. And so as I move everything pi over 2 to the right, this 0 becomes pi over 2. Then this one becomes just pi. This third one becomes 3 pi over 2. The fourth one becomes 2 pi. And then 2 pi goes to 5 pi over 2. I just thought about that really quickly because it'd be like 2.5 pi, and that's 5 halves. That's what happens if I add 1/2 pi to 2 pi. So that also would be a 0. So as you can see, my zeros now are pi over 2 and 3 pi over 2, and also 5 pi over 2, and a lot of you put that as an answer, but this says we want to find the x-intercepts that occur between 0 and 2 pi. So 5 pi over 2 is too big. It is definitely bigger than 2 pi. It's 2.5 pi we just saw. So I don't need that one. The only ones I would need would be pi over 2 and 3 pi over 2. Those are the only x-intercepts that occur between 0 and 2 pi. I'll go ahead and go into the challenge here, just so that those of you who want to try it can have an opportunity. We wanted to find the expressions for sine, cosine, and tangent, and so sine is opposite over hypotenuse. Well, there is no opposite side right now. The hypotenuse is x, so this will be over x. We'll need to get something for the opposite side here. Let's go ahead and just call it y for now. And so we'll say y squared equals x squared minus 7 squared. So y squared equals x squared minus 49. Y equals the square root of x squared minus 49. Now, I really hope none of you decided to make this x minus 7, because this is definitely not true. So just make sure we don't do that. And really, we just have to leave this opposite side as the square root of x squared minus 49, because we wanted it in terms of x. we couldn't just introduce a new variable for ourselves. So this is the square root of x squared minus 49. That's our opposite side. Cosine is adjacent over hypotenuse, so just 7 over x. And then tangent to y would have been square root of x squared minus 49 over 7. Finally, this one is going to have a couple different things going on. First, the amplitude is going to be doubled, and the whole graph is going to shift up 3, but we got to worry about two different things happening within the parentheses here. The first is that the period will equal 2 pi divided by 2, so the period is just pi, but the phase shift is actually not just pi, it is pi over 2. Phase shift is c divided by b. C here is pi, b is 2, so we have a phase shift of pi over 2. This is the reason that I like to rewrite anytime I have a c and a b, I like to rewrite it in this form. Basically factor out b from both terms inside the parentheses. It's still an accurate statement, you'd see. If I do the distributive property, I still get the exact same thing in the parentheses I had before, but now I can see that this pi over 2 is our phase shift. So I'll start with my normal sine points of, let's see, maybe I'll do it over here. Start with my normal sine points of 0, pi over 2, pi, 3 pi over 2, and 2 pi, which is 0, 1, 0, negative 1, 0. I'll go ahead and take care of the things that happen to my y first. Everything is doubled first, so that becomes a 2, that becomes a negative 2, and then I'll send everything up 3. So this becomes a 3, 5, 3, 1, and 3. So those are my y's. I've taken care of that now. Next, we're going to go ahead and adjust the period by dividing 2 away from each of our x's. So that ends up making all of our x's half as big, but so that's 0 still. This is pi over 4. This is pi over 2. This is 3 pi over 4. And this is just pi. And then still we got 3, 5, 1. I'm sorry, 3, 5, 3, 1, 3. And now I'm going to send everything 2 to the pi over 2 to the right. So this 0 becomes pi over 2. This one would go 3/4 pi. This one would be full pi now. This one would be 5/4 pi. And then this one would be 3/2 pi. Yep, so I can tell that I've done it right. I started at pi over 2 to the right. I ended one period later, which is a total distance of pi. That should always happen like that when I've set it up here. And so let's just start an axis. And we'll decide to start at pi over 2. And we'll count by pi over 4s, I guess. It's 3 pi over 4. Just kind of wiggle out the first one to indicate I didn't care about the scale until I got to my first point. Here we've got pi, 5 pi over 4, and 3 pi over 2. And we went 1, 3, and 5. Sorry, I just slowed down because I just realized I've made a mistake the whole time. This is a cosine graph. Cosine graph the whole time, and so I had messed up my y's the whole time. You're probably sitting there the whole time being like, wait, stop, it's a cosine graph. It should have been 1, 0, negative 1, 0, 1. And so then when I doubled them all, 2, negative 2, and 2, moved them all up 3, I've got 5, 3, 1, 3, 5. Okay, so my points would be here at 5, then 3, then 1, back to 3, 5, and I finally got my cosine graph. All right, so again, this formative is definitely indicated to me we need more practice before we get to the summative on Friday. So please make sure you've practiced and come in and ask for help.